Here we have the percent of families that had 3 or more children between 1960 and 2000 is approximately this P of T. So I'm already given one of my units. It's percent of families, and sometimes, I know if it's percent, everything feels like it should be a percent after for some reason. I know there's percent ones in the homework to kind of confuse you, but just because it's percent in this example and on a couple of the homework problems doesn't mean it's always percent. But for this one, our output is percent. Just be careful that everything doesn't become a percent from here on out. That had 3 or more children between 1960 and 2000 is given by this P of T, and T is measured in decades. So our measurement is not years or hours, it's decades. And T equals 1 corresponds to 1960. So our input is decades, and we get out the percent of families that had 3 or more kids. So the first part says what percent of families had 3 or more children in 1960, and then it says what about in 2000. So remember, on all these word problems, we're plugging into, it could be the original, and if you see change, that means it could be the slope if it says average change, or if it says change at an instant, then it's definitely the derivative. But this one, I don't see the word change at all. It just says what were the percent of families in 1960 and then in 2000. It doesn't say how fast were they changing between those 2 years or anything like that. So if I don't see the word change, I'm going to plug into the original for 1960 and 2000, but I needed to figure out the T values for these. So 1960, what is the T value? Well, it's given to be 1. So take a second. What's the T value for 2000 then? What's the T value for 2000? Be careful because it's in decades, and also don't be afraid to count on your fingers. So T equals what? Well, 1 is 1960, 2 is 1970, 3 is 1980, 4 is 1990, 5 is 2000. So don't be too proud. Count on your fingers if you have to. It's T equals 5. We can double check that. 60s, 70s, 80s, 90s, 2000. 5 for our T value. So we're going to plug in T equals 1 first into the original. So we have P of 1 is 35.7 over 1 to the 0.18. Well, 1 to any power is always 1. So 35.7 divided by 1 is just going to be 35.7. What's our units on this? It's the original, so it only has 1 unit. And our output for the original is percent of families. So about 36% of families had 3 or more kids in 1960, which is a lot. What do you think is going to happen in 2000? Let's see here. P of 5 is going to be 35.7. Then I'm replacing that T with a 5 to the 0.18. 35.7 divided by 5 to the 0.18, you should get 26.72% of families. Do these answers make sense? Well, first of all, they're between 0 and 100%, so that's always a good sign. We don't want to get like 600% of something. So the numbers themselves sound good. And then just thinking about real life, about 36% of families had 3 or more kids in 1960, and that dropped to about 27% of families in 2000. And that to me makes sense because the cost of living went up. So just being able to afford having that many kids, it makes sense that less families did. Although I'm one of 5 kids, so who knows? I guess lots of people still have big families, but it makes sense in general it was going down. So the next part says, what was the average rate of change in the percent of families having 3 or more children between 1960 and 2000? So we're asked for average rate of change. What does that mean? Slope or derivative? It means slope. So you can plug into the original. It could be a slope problem or it could be a derivative. This one is a slope formula because it's average between 2 years, not change at just one instant. So I want to compare this by plugging into the slope formula. So I'm going to do P of 5 minus p of 1 over 5 minus 1. The nice part about this slope formula is we already have these y values from above, right? P of 5, our y value was 26.72, minus P of 1 from above was 35.7. So our answers are actually found in the first part. So we've already done some of the work. And then we're going to divide that by 5 minus 1, which is just 4. So 26.72 minus 35.7 is going to be negative 8.98 over 4, which ends up being negative 2.245 what? It's 2 units because it's a rate of change. So the units in the numerator, we're measuring the percent of families over the units in the denominator. Be careful, it's not years, it's decade. So there were negative 2% of families having 3 or more kids? No, it's a rate of change. So how we would interpret this is we would say on average, the percent of families with 3 or more kids is what? On average, the percent of families with 3 or more kids is increasing or decreasing based on this negative slope. It's decreasing. By how much? Well, decreasing by a negative would make it sound like it's a positive because a negative times a negative makes it a positive. So we're going to say decreasing by, not negative 2, by about 2% per decade. When you say decreasing, that already accounts for the negative. So on average, the percent of families with 3 or more kids is decreasing by about 2% per decade, which makes sense to me, again, because just the cost of living goes up. You can't really afford to have all these babies. So the last part says, how fast was the percent of families that had 3 or more children changing in 1960 and then in 2000? So we're just going to compare how fast it was changing between these 2 decades. So it doesn't say on average or anything like that. It says what's the change in 1960 and then what about in 2000? So we're going to take the derivative. So we're talking about change at an instant and then we're comparing it to another instant. So let's rewrite that function so that we can see it down here. We have P of t is 35.7 over t to the 0.18. So dang, I have a fraction. Do I have to use the quotient rule? Well, I don't have t's or x's, whatever your variable is. In this case, it's t's in the top and the bottom. So I don't have to use the quotient rule. I just need to rewrite this as a negative exponent. 35.7 t to the negative 0.18. Okay, so did we take the derivative? No, all we did was rewrite. But now we are ready to take the derivative. So I'm going to call it p prime of t. And I'm going to look at this one here. I'm going to keep the 35.7. I'm going to bring down the power, which is negative 0.18, and raise t to the what? Negative 0.18 minus 1 is going to be a negative 1.18. And you could multiply these together out front if you want to. I will for this one, just in case you don't have a graphing calculator. It makes it easier on a scientific calculator to combine these, so you get negative 6.426 t to the negative 1.18. There's your derivative. And now we can plug in and compare. So off to the side here, we can do 1960. That's t equals 1. So we're going to do p prime of 1 which is negative 6.426 times 1 to the negative 1.18. Plugging in 1 for that t there into the derivative. And the instantaneous rate of change in 1960 ends up just being negative 6.426, right? Because 1 to any power is 1 times negative 6.426 is going to stay that number. And we need 2 units on it, so it's the percent of families per decade, or just percent per decade is fine. I know it's a lot to keep writing. So in 1960, what do we have up here? We said there was about 36% of families having 3 or more kids, but that was expected to what? Increase or decrease? The derivative is negative, so it was decreasing by about 6% that year. So it started out at about 36%, but is expected to decrease by 6% that year. And comparing that to 2000, which was t equals 5 from above, we're doing p prime of 5. So you're grabbing your calculator, you're saying negative 6.426, and we're replacing it with a 5 this time instead of a 1 to stand for 2000, to the negative 1.18. So when we plug in, what you should get is negative 0.962% per decade. So pretty different answers from the average. The average was it was decreasing by about 2%, when in actuality in 1960 it was decreasing by 6%, and then in 2000 it was decreasing by about 1%. So that just shows you the average rate of change can somewhat estimate what you have, but only if you make the interval really small. So we don't want to go across all these decades and expect it to be perfect. It just estimates what these instantaneous changes are going to be. And this answer makes sense to me because they're already down to only 27% of families having 3 or more kids. They can't keep decreasing by like 6% or something huge because they're already at a smaller number, and then they're decreasing by just a little bit.